So we continue to look at the fundamentals of precalculus, and the last section that we'll look at is the coordinate geometry. Now, with coordinate geometry is that you put everything on the coordinate plane or Cartesian plane. So it's got the y-axis and x-axis. This is when you are dealing with 2 dimensions. This can go on to include other dimensions. Okay, so this is 2 dimensions. And so what is crucial is that we need to be able to understand that once we have this plane here, we can actually put points on there and be able to get various distances. Could be maps, could be some other readers that you are, real-time readers. You're calculating maybe distance between 2 events. So that could be application. So you can calculate the distance. Once you do the distance, that distance you can actually look at its midpoints. Midpoint is very crucial because that you can apply when you're doing the equation of the circle. That relies on distance as well. The other concept that we can get from this is the gradient of the line that you can use to formulate the equation of the straight line. So basically, the gradient is change in y against the change in x. So it will tell you how much there is a variation in y compared to the variation in x. So for example, here, this tells you how much y is changing with regards to how much x is changing. So for example, if I've got a line like this, I'll be saying that y is not, x is not changing whilst y is changing. When I have something like this, x is changing whilst y is not changing. Sorry, not 0, y is constant, okay? So we're saying that y is constant at that point, okay? Then, so we can use this to calculate the equation of that straight line, okay? Another concept that we can do is, now we've done a lot of quadratic equations, so you can actually sketch the equation onto, or the quadratic expression onto something like that. It could be like that, or it could be this way. Depends. So these have got various applications in mathematics. So you need to know the general form. When is it facing up, down? When is it facing up? And things like that. So all these points is what this video is about. So we'll take it from the beginning here, okay, all the way till we get to the coordinate geometry, and everything here is actually in a way connected. So this will be fun. Let's get on to it. Plane. This is also known as the Cartesian plane. Now we are going to look at just the one that is in 2 dimensions. And one thing that we've already explained is that this is also used to visualize or solve algebraic equations or inequalities. So now the Cartesian plane is, these are 2 lines which have got real numbers like that. Okay, they've got real numbers. And so you have these 2 lines or real lines that are perpendicular to each other. And so they meet at a point where it's 0, 0. Then you have the first quadrant, the second, the third, the fourth, like that. Why this is like this is like, normally we go like this when we look at this. Okay, so the first will be there, the second, the third, the fourth will be there. Doesn't really matter. It just depends on, these are just labels. So you just need to know that this is 90, 90, 90, 90 degrees, like that. So the first, second, third, and fourth. So here you have positive, positive, and positive. Here you have positive and negative. Here you have negative and negative. Here you have positive and negative planes, like that. Okay, so then the other important concept to understand here is that each point on this Cartesian plane is represented by coordinates, which are x, y. Okay, here it will be negative x, y, like that. Here it will be negative x, negative y. And then here it will be x, negative y. Generally, though, is to say that this is x, y, x, y, x, y, x, y. But I'm just showing you the signs.